Alright, welcome to our 11th video of AP Unit 7. This one's a brief one talking about some exceptions in electron configurations. To be honest, they're not of extreme importance to you. They're just a little bit of memorization. But you may see some weird configurations every now and then, and I need to explain, basically tell you that that's okay. So, basically, certain elements, their ground state configuration is going to appear to violate the rules that we've been discussing for the past 5 videos. They're not going to quite, well, you'll see. So for example, the electron configuration of chromium, at least noble gas wise, is actually argon 4s1 3d5 instead of 4s2 3d4. Now, this is what we would accept in general and honors. This is what you're kind of expected to do in AP. Now, I will take either of these, but you need to understand, in my opinion, it helps to understand why. So we have the top one. Let's start with the bottom. We have 4s2 and 3d. So that would say up, down, up, 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 up. All right, now let's think of shells. Argon would have nucleus, basically a full first shell, a full second shell, a kind of almost full third shell, and a barely touched fourth shell. Because in its third shell, it has 3s2, 3p6, and 3d4. So it's like 4 or 5 electrons away from having a fully stable third shell. And then it realizes, well, actually, this is going to be hard, so it moves up a couple to 4s. Now, put simply, what you got to know is that this current state is not very stable. However, this is quite a decent bit more stable. If I were to have one in everything, that is not nearly as stable as having a full set of orbitals. That's not even an option. And if it could, it would try to get to the full configuration. It can't. Metals don't have very high electronegativity. They're not good at taking electrons, especially 5. So what it does is it basically takes one of these and moves it into its D block. So it kind of gives up on fully finishing the 4s. And yes, the 4s2 is kind of stable. You had a full orbital. But that was the only thing on the outer level. All it really has to do is try to give away 1 electron now. And then everything it has is on 3D, or the third shell. Now, again, it's not super stable. But this at least is kind of like a minor stability. Keeps it a little bit more stable. So that's its normal configuration. It will tend to move 1 over. And this actually happens for a couple ones in that same column. So, as I mentioned, copper typically is actually 4s1 3d10 for a very similar logic, and even more so in this case, because copper can actually, fill its 3d orbital, and its third shell is filled. But instead of 4s2, this is also where some of the multiple charges come in. Because copper can typically copper 1+, or I think I've seen copper 2+ before. The 1+ is when it gives away this 4s electron. The 2+ is when it gives away both of its 4s electrons kind of at the same time. Now, 1+ is, I'm pretty sure, going to be a little bit more common because, again, then its third shell is filled. But that's where kind of the multiple charges come in. Sometimes it gives away all its valence. Sometimes it gives away, it kind of gives away half of it and uses the other half for itself. It just really depends on what happens. I honestly don't know what makes them go 1+ versus 2+. Yeah, so. Okay, that is largely, again, a consequence, especially of the 3D and 4s. So going back to Aufbau's, basically electrons fill orbitals with lower energy. And if you were to compare the energy levels, so this being like the 2s, or the 3s, 3p, 4s, 3d, they're not, it's really hard to see this, I'm sorry. They're really close. So there's not a huge difference between the forest and 3D. The forest is just a little bit lower, which means it's not that hard for them to take an electron and move it up to the 3D. It's not a huge difference. So that frequently will occur, that kind of shifting one electron back down, when there are enough electrons to form precisely half-filled sets of degenerate orbitals, meaning they, basically put one in everything. If they're able to get one in everything, they're going to try and do it. Or even more so, when you can actually completely fill the D subshell, as in copper, instead of just leaving it at, we're one away. Lastly, there are a few cases among the heavier transition metals. So with 5D, 4D, or 5D orbitals, that does happen kind of in the same column. Not as common as iron and zinc, chromium and copper. I don't know why, but it is common. And there's one or two on the F block that'll actually take one from the S and fill the F. It's just kind of weird. But again, not that big a deal for you. Don't worry about it too much. Just wanted to show you that, hey, these can happen and it's fine. Thanks for watching.